All right, my friends, welcome to this time's presentation of DBA Fundamentals Group with execution plans. Where do I start? With Hugo Cornelis. Today is May 16th, 2023, and you have yet again joined us in the DBA Fundamentals virtual group to make everything work. In the top right-hand corner of the screen, you should see the three names of the leaders from the DBA Fundamentals Group: Steve Cantrell, Shane O'Neill, and myself, Kevin Wilkie. Right to the right of our names, you'll actually see our Twitter handles, so you can easily get hold of us. If for any reason you need any of the three of us, that's probably the easiest way to get hold of us. Obviously, there's always the DBA Fundamentals Twitter handle if you need to get hold of us that way. Below our names, you'll actually see the various social media platforms we are actually part of. The easiest way to get hold of us is to see us on Meetup, where we actually have all of our stuff, and all of the Azure tech groups are on there as well. I believe right now there's 154 tech groups on Azure. So easiest way to find all of us is on Meetup. And if you find us, the easiest way is on Meetup. You'll see all of our meetings that we're going to have over the next few months. Below that is our website, dbafund.org, where you'll find all of our previous and our upcoming meetings, so that you'll see what we're going to talk about and any of the past things we have spoken of. So below that is dbafundtube.com, our version of YouTube, which actually has all of our past presentations. So when you're out there, please be sure to actually hit the like and subscribe button so that you can see any of our presentations when they actually go live, and you'll see it right away. Below that is our other other handles. Twitter, we're at DBA Fund, and we also have a Slack channel and a LinkedIn group. All of our session recordings are usually available within 1 to 2 days. As I said earlier, check us out on our YouTube channel, dbafundtube.com. Just a reminder, be sure to turn off your video and mute yourself. I'm actually going to turn off my video here in just a second, so you don't have to see how pretty I am and can watch Hugo tell all of the goodness. Also, be sure to type any questions you have into the chat so that we can all learn from it and we can actually have Hugo answer them right away. All right, and with that, the brief synopsis of Hugo's everything he's done. So with that, I turn it over to Hugo for more goodness.
Thank you, Kevin. Thank you very much, and thank you for having me. Let me try to share my screen. I believe it was screen 2. And you should all now see my screen.
We do.
Great. So welcome to the session Execution Plans. Where do I start? And as the name implies, this is an absolute beginner session. And it is an introduction to execution plans. I'm going to try to teach you the basics of reading and working with execution plans. My name is Hugo Cornelis, and I make SQL Server Fast.com. SQLServerFast.com is a website where I am trying to collect all my knowledge about execution plans. And one of the things I built there is the execution plan reference. As the name suggests, it's a reference where you can find everything about basically everything in execution plans. I target that reference for completeness. It is not a beginner level resource. It's not a teaching material. It's targeted towards completeness. For people who want to learn, I am busy recording an extensive set of videos, the execution plan video training, where I explain everything at a basic and then also at an advanced level in separate videos. Some of those videos are available for free. Others, for others, I ask a small contribution. But if you purchase access to any of my videos between now and June 15th, you can use the code DBA Fund, and that's not a hedge fund, it's short for fundamentals, to get 10% off on the price of the execution plan video training. I have a lot of other content on SQL Server fast.com as well, like my blog, articles, and resources. And what I especially want you to look at is the resources for presentations. You go in the menu to other, then to presentations, then to presentation resources. You will see a list of all my sessions. This session should be included. You can just click that session and then you will find a link to download both the slide deck and all the demo code I'm going to use. The most important part I want to tell you about myself is basically my contact details. I don't like to talk very long about myself. You're not here to listen to me talking about me. You're here to listen to me talking about execution plans. But it is possible that you have questions and you don't get around to asking that question during the session. Maybe it's too busy. Maybe I run over. Maybe everything I tell you is still brewing in your head and the question pops up tomorrow. All those things can happen. Do not hesitate to drop me an email or add me on Twitter, and I will try to answer your question to the best of my competence. So today's session, execution plans, where do I start? The agenda we're going to work through is 5 points. First, why should I care? I'm very happy to see that there are so many people here. The fact that you are here proves to me that you probably already have a hunch why execution plans are important. But I'm going to, apologies. I'm going to explain it anyway, just so that we're all on the same level and so that you have a good way to tell others why execution plans are important. Once you really care about execution plans, you obviously want to know where to find them. So I'm going to show you where to find them. And then you have an execution plan and you need to learn how to read them. So we're going to talk about that. A very important part of execution plans are the properties. So we'll spend some time on those. And at the end of the session, I'm going to run through one or two slightly more complex examples to put all the things together and see how it all comes together when you apply it to a real execution plan. So let's start with the first point. Execution plans. Why should I care? Why bother with execution plans? To understand that, you have to understand that there is a huge difference between traditional so-called third generation of procedural languages such as C# or C++, Visual Basic, JavaScript, and tons of other languages versus SQL, which we'll talk about a bit later. So to understand that difference, let's first focus on those traditional third generation languages. In those languages, you give a step-by-step description of what the computer should do. To give a similarity, if I describe my morning routine as a third generation procedural language, I would describe it as wake up when the alarm goes off, hit the snooze button, wake up again 7 minutes later, switch off the alarm, get out of bed, go to the bathroom, take a shower, towel off, brush my teeth, get dressed, go to the kitchen, have breakfast, go in the car, drive to the office, start browsing I mean, start doing work. So that is step by step how my morning routine looks. And if I make a mistake in that step-by-step description, we call that a bug. For instance, I could make a mistake where I first get dressed and then take a shower. That doesn't result in the intended effect. But there are also changes I could contemplate that still result the extended in the that still result in what I want, but more or less efficient. I could, for instance, choose to brush my teeth while I'm showering and save some time. I could choose to, the night before, prepare some sandwiches, grab them quickly and eat them while I'm stuck in traffic on my way to the office. That should save even more time. So those are choices that do not affect the outcome, but do affect the performance of the routine. And those are choices I myself can make. Now, applying that to computers, computers often have to deal with large collections of data, and that means that most third generation languages have loops where they deal with those collections. They load the first element in memory, do something on that, read the next element, and repeat that until dawn. But even then, there are multiple ways to do this. And when it is more complex, when you have to combine data from different sources, then you get a lot of ways to achieve the same thing. And like I said, it's the developer who chooses the algorithm. It's the developer who chooses whether I brush my teeth before showering, after showering, or while showering. So if the algorithm runs too slow, we can blame the developer because they are the one who wrote the code. They are the one who can fix it. So that's how a third generation language works. But SQL is not a third generation language. SQL is a so-called fourth generation language. And I'm here talking about SQL, not about T-SQL. T-SQL is one of many different SQL dialects. So pure SQL, which we can find in many databases, is a so-called fourth generation language, or um, I forgot the term and it's not on the slide. Um, But anyway, what you do in SQL is you give a concise description of what you want the computer to, what you want the final result to be without bothering about the steps. So again, thinking about my morning routine, I just described my morning routine as a third generation language. But my boss could send me a text message saying, Hugo, we have an important customer in the office tomorrow, so make sure you are there at 8 sharp and make sure that you are dressed representative. That's all she will tell me. She doesn't care whether I brush my teeth before or after showering. She doesn't care whether I have a long breakfast with my wife, setting the clock very early so that I have the time for that, or whether I eat my sandwiches in the car. She only cares that I am there at 8 or before and not in any of my offensive t-shirts. So she leaves it to me to come up with the algorithm, to come up with the steps, as long as the end result is as she wants. That's how SQL works. We tell the database, this is the result we want. We don't care how you get there, as long as you get there. And we do this in a set-based way. The result is described by applying set logic to input collections, or rather input sets. Everything is considered a set in SQL. So the logical description of a query pretends everything happens at once. Now, in reality, a computer can never do everything at once. In reality, computers still process one element at a time. Okay, you can have parallelism, and then every core is working on one element at a time, but still, every process steps through the elements one at a time. So there is some translation somewhere where this set-based logic that I have written, the query, is translated into an algorithm where one step at a time, the data is transformed from its base form in the table to the form that the query specifies as the end result. And that's where the so-called query optimizer comes in. The query optimizer is a piece of logic in SQL Server. It represents thousands upon thousands, maybe even hundreds of thousands of engineering hours of constantly improving on previous versions, using feedback from customers, using metrics they currently have on Azure where they constantly measure performance. And all that logic is used to help SQL Server to try to come up with the best algorithm for each query. But it's still done by a computer program, and computer programs don't always work perfectly, especially when there is so much complexity at stake. So the query optimizer doesn't always get it right. The query optimizer is amazingly smart, but it's not infallible. But it's the query optimizer that chooses the algorithm. So when the database runs slow, obviously my boss will not blame me, right? Oh, the slide says something else. The slide says that my boss will blame me, and that is correct. My boss will blame me and will expect me to fix it. And if I tell my boss, hey, I can't help it, it's the optimizer's fault, she will ask me, what are we paying you the big bucks for if you can't fix this? And she is totally right. That is my job. So now I need to find a way to fix this, even though I didn't cause the problem. The optimizer caused the problem, but I need to fix it. Now, specifically on SQL Server, now we're talking about Transact SQL or T-SQL. T-SQL is, in fact, a mixture of third and fourth generation languages. So it mixes set-based queries with procedural code. That means that there are multiple reasons why code can be slow. It might be that you are executing code that uses lots of procedural stuff. Maybe it uses a cursor or something else to iterate over rows in a data set. That is not a good idea. There are database systems where that works fine. I've heard, I don't know from personal experience, but I have heard that Oracle runs fine with code like that. SQL Server doesn't. SQL Server has right from the start, right from the very first versions back in the 80s or so, always been optimized towards executing set-based code as fast as possible at the expense of the performance of procedural code. So if you have lots of procedural code, try to rewrite it as set-based code. But sometimes a single query is slow. Maybe because your entire code is a single query. Maybe because you have a lot of procedural code, but monitoring individual steps in the code, you see that one query takes 5 minutes and all the other steps combined are 5 milliseconds. Well, then you don't have to bother about all the other steps. It's the 5 minute query that is causing the slowness. So that's where you know this single query is slow. The optimizer picked a slow algorithm. And now you're wondering, what algorithm did it pick? And that's where execution plans come in, because the execution plan shows you what algorithms were chosen by the optimizer. And if you want to fix a problem, you need to know the root cause. So that is why you should care about execution plans, because the execution plan shows you the algorithm, which means you can read the execution plan, study the execution plan to understand why it is slow. And that should give you a clue where you can start improving the performance. Hopefully you now all understand why execution plans are important. Are there any questions at this time?
No questions as of yet, Hugo.
Then I will just race right on. So hopefully I have convinced everyone now that you should care about execution plans, and now you want to find them because you care. Now, this question is more complex than it sounds because you can interpret it in different ways. One is your production DBA. There are thousands of queries running all the time, and you have a reason to find problem plans. Maybe the entire server is running sluggishly because multiple queries are a bit slow and it's using too much memory or too much CPU. Perhaps a single process that is supposed to finish in an hour suddenly takes 2 hours. Perhaps people are complaining that the online environment isn't responding fast enough on the search screen. And you have to find which plans it is. This is out of scope for today's session. I'm not going to talk about that. But there are multiple ways where you can find that, like the plan cache, the query store, extended events, trace. I'm not going to talk about trace, monitoring tools, various DMVs. Like I said, they are out of scope for this session. At the end of the session, I will have a slide with various resources for further reading. One of them is a book by my good friend Grant Fritchie that does cover all of these tools. But I will not talk about them. I will talk about the situation where you already know that one specific query is too slow. And you want to find the execution plan so you can start troubleshooting. So we already have the query. Maybe you are a developer, you have just written new code and you want to make sure it behaves before pushing it in production. Do you have any such developers? I wish I had. Or maybe you are a developer and your DBA just came back and said the code you pushed in production is too slow. Fix it. Or maybe you are a junior DBA and your senior DBA gave you some queries to fix because they are busy setting up high availability, but the performance problem still needs to be fixed. There are tons of scenarios where you have a query and you need to find a way to optimize it. And you want to find the execution plan. Let's look at how you can handle that. So let me jump into my demo environment. There we go. And my first demo, it's a very simple demo. And let me tell you, if you ever find code in your production that literally calls a function called delay, then you don't need an execution plan to understand why it's slow. This is a CLR user-defined function that literally just calls the wait function to cause some delay, to make a query slower. I have created this specifically for this demo and a few other demos where I needed to slow down a query. Let's assume that this is a real query, so it's not 6 lines, but 500 lines. Let's assume that there is no obvious reason for slowness and that you actually need to find a way to fix the performance. The first way to get an execution plan is to ask for the execution plan only. You can do that by using this button on the toolbar. It's marked display estimated execution plan. An execution plan only is sometimes called an estimated execution plan. I don't like that term. I will come back later to the reasons, but it is a term that is used in the tools and that a lot of people use in their talks and their blogs as well. I avoid that term because it is misleading. I call it the execution plan or the execution plan only. If I click this button, you will actually see two execution plans. And that's because this batch has two statements. One statement is the use statement, the other statement is the select statement. If I want to see the execution plan for only the select statement, then I highlight that statement, I click the same button again, and now I get an execution plan for only the highlighted text. I'm not going to talk about the contents of the execution plan yet. I'm just going to show you that this is one way to request an execution plan. Now hitting Control R to go back to just the window only. This is the way to shut the lower window. There is a second way to get the execution plan, and that is called the execution plan plus runtime statistics. For that, you have to use this button. It's called include actual execution plan. Just as the execution plan only is sometimes called the estimated plan, execution plan plus runtime statistics is sometimes called the actual plan. If I click this button, nothing happens. Except when I remove my mouse, you see that now the button has changed. This button is an on-off switch, a toggle. By clicking it, I have enabled an option, but nothing else. And I'll zoom out. You will see I can enable it, disable it as often as I want. But if it is enabled, like it is now, then when I execute the query, this will take some time because the query is slow. But eventually, when the query execution is completed, I think it's about 15 to 20 seconds, then you should see a third tab appear in the lower part of the window. You already see a results and a messages tab, and there is the execution plan tab. If I click that tab, you once more see the execution plan. And if you have remembered what you saw the previous time, you will notice that this execution plan shows a bit more information. That's part of the runtime statistics that are now included. But you will also have noticed that the execution plan only appeared when the execution was completely finished. So we had to wait 16 seconds. 16 seconds is not a problem. But what if this query had run for 16 minutes? You need to fix it fast, but you have to wait 16 minutes before you can even start doing your work. That is one of the problems with the execution plan plus runtime statistics. It's a great tool because it has way more information, but it has its limitations because, and one of the limitations is that you only get it when execution is finished. Now there is one way around that, and that is to use another on-off switch, the one next here, marked include live query statistics. That enables the execution plan with live statistics. If I click this again, the switch is turned on. Nothing happens immediately, it's an on-off button. But now, when this option is enabled and I execute the query again, you will see that immediately an execution plan appears. And then as the query is executing, Management Studio constantly polls SQL Server to ask how far execution has proceeded, and it updates some of the live statistics on your screen while it is running. So those are the three ways in Management Studio to request execution plans. If you're working with Azure Data Studio, then the execution plan only and the execution plan plus runtime statistics, called estimated plan and actual plan, are also available. There are no live statistics in Azure Data Studio, at least not yet. Perhaps they're working on it, but at this time that option is not available. So let's recapture the three options. We have the execution plan only. This is called an estimated execution plan by many people and by the tools, but it's a confusing name because it is not an estimated plan. SQL Server doesn't have a process to estimate a plan. There is only a process called the query optimizer that will compile a plan for a query. So when you request an execution plan only, there is not a specific request going to SQL Server, hey, do a quick estimation of the plan. That is simply not possible. If you click that button, Management Studio will tell SQL Server, give me the execution plan for this query that I want to execute. And the optimizer will produce an execution plan. And the optimizer will say, hey, here's the execution plan. Go ahead, execute it. And then Management Studio will say, haha, fooled you. I never intended to execute the query. I just wanted to see the execution plan. And now I know how you would have executed it if I actually had executed it. So it's exactly the same execution plan. If you ask for the execution plan only, you will see the execution plan that will be used to execute the query. And yes, it says on the screen there are some exceptions. Those exceptions have to do with rare specific situations where after initially compiling the execution plan, at a later point during execution, something happens that necessitates a recompile. So in that case, the plan was not estimated then replaced by an actual plan. No, the plan was computed and then replaced by a new actual plan. So that's why I hate the term estimated execution plan. The second option is the execution plan plus runtime statistics, or for short, execution plan plus. And like I said, actual execution plan suggests it can be different from the estimated execution plan, which is not the case, except when there was a reason to recompile the execution plan. So here the process is, we ask the query optimizer to create a plan because we want to execute the query, just as we did for the execution plan only. The optimizer compiles a plan that can be used to execute the query. But now we are actually going to use that plan to execute the query. And while the query is running, we add runtime statistics to that execution plan. So we don't only have information about what the query optimizer thought is the best idea to execute the plan, but we also have information about things that happened while the plan was running. And those additional runtime statistics can be a great resource to troubleshoot issues with an execution plan, which is why I love to work with an execution plan plus runtime statistics, except when I have to wait 18 minutes before I get it. And then the execution plan with the live statistics, once more, we ask the optimizer, here's a query, we want to execute it, give me the execution plan. The optimizer gives us the execution plan. And now we first display the plan, and at the same time we fire the query. And then the tool, Management Studio, keeps pulling some hidden DMVs in SQL Server to update all the elements within that execution plan as the query is running. I personally love to use this if there are long-running queries, because I can immediately see the plan, but I can also see those counters. And sometimes, already within the first few seconds, I can see that something is happening different from what the optimizer expected. Sometimes I cannot see that and I still have to wait, but at least I had a shot at finding the root cause earlier. However, the execution plan with live statistics has just a subset of the statistics, not all of them. And that's why I often, when I work with long-running queries, enable both the execution plan plus runtime statistics and the execution plan with live statistics, so that while the query is executing, I can already start looking to see if I see any issues. And when the query has finished, I can switch to the execution plan plus to have even more statistics available. I'm not going to talk through all the columns and all the rows in this comparison graph. You can watch it later. It is in the slides, so you can download it later and look through it and even mail me if you don't understand anything. But this is a short overview of the most important differences. Before I talk about how to read them, are there any questions now?
No, we're just having a fun discussion about Chat GPT and if it will ever go into the execution plan itself.
For now, I hope not. There was a very recent T-SQL Tuesday challenge to write about ChatGPT, and I have tried to use ChatGPT to ask some questions about execution plans and even to have it tune a query. Go to my blog and read how devastatingly bad ChatGPT is at that. When I asked about generic parts of execution plans that are well documented on the internet, it had a bunch of good practices assembled in such a way that the result wasn't entirely correct, but sounded dangerously close to correct. I realized it was wrong, but a lot of people would fall for it. When I asked about obscure elements in execution plan, it completely made up an answer that completely missed the ball. And when I asked it to tune a query and optimize it, it returned a query that gave me a different result and was slower. So for now, even if ChatGPT is integrated in a tool, I will not use it. And that's why we still need to work with execution plans ourselves to get back on track. And I will talk about how to read execution plans. Because you just saw an execution plan, and here is another example of an execution plan. And it looks pretty. It's a nice picture. But if you have no clue where to start, then it's just a pretty picture. So to start understanding it, you have first, we'll need to dissect it into its two basic elements. One element are the icons. There are different icons, they look different, but each of those icons represents an operator. And an operator is basically a small program that does something. They all do something else, but they all do something. I'll get back to it in more detail later. But first look at the second element, and those are the arrows. And the arrows represents the flow of data. And technically speaking, they don't even exist. They are not actual elements of the execution plan. I'll get back to that as well. But let's first dive a bit deeper into those operators, those icons, those small programs that do something. Every operator, if you look at the programmability level, and that's not our programmability level, but the SQL Server programmability level, so where the engineers working on the SQL Server engine work with, for those SQL Server engineers, every operator is basically a program that has three entry points, three functions, three, whatever, there's a different term for it in object-oriented programming, but I forgot the term. Methods, that's the word I was looking for, three methods. And those are initialize. So when we ask an operator to initialize itself, it will prepare to do work. Obviously, whenever an execution plan runs, every operator will first be called with an initialize call. However, sometimes during execution, an operator is initialized a second, third, fourth time. That will basically reinitialize it and restart from the top, do it all over. Now, you might expect that that means it's going to do exactly the same. But some operators have basically, let's call it parameters, that affect how they work. And those can be changed on a reinitialization. So if you have an operator that goes into a customer table and reads all data from a specified city, then it can first be initialized with the city New York. The second time it can be initialized with the city Chicago. It will two times do the same thing. It will two times return all customers from a specified city, but it will not return the same customers because the specified city is New York in the first time, Chicago in the second time. And that's one reason why sometimes reinitialization is used. Sometimes reinitialization is definitely used to exactly get the same data again, but that is more rare. The most important function of every operator is the get next call. Get next is the heart and meat of every execution plan. It simply returns a single row to the calling operator. So an operator is asked, give me a row. That is basically what get next does. And how the operator produces a row is entirely dependent on what operator this is. But in many cases, that means that the operator itself has to get data to work on by calling other operators, also on their get next method. So an operator is asked for a row, and one thing it does is, I need my own data first. Someone else give me a row so that I can do my work. Finally, there's the close call that's always used at the end. It clears up memory use, etc. It's completely uninteresting in the context of reading execution plans and studying performance. It's just good to know that it's there so that we're not leaking memory all the time. Now, the term operator can be confusing because it basically means two things. One meaning of the term operator is a generic type of operator. I already mentioned at the start when I introduced myself, I work on the execution plan reference. If you go to the execution plan reference and you look up the filter operator, one of the sentences in the description is that the filter operator applies a predicate to its input rows and returns only rows for which the predicate evaluates to true. That sounds a bit complicated. And basically it means the filter operator asks it receives rows, does a test on them, and only passes those that pass the test. But in a reference, you want to be very precise, and that sometimes means that your wording is a bit more complicated. But this is a description that applies to this generic type of operator. Every filter operator does that. It's a class. However, the same word operator is used for an instance of an operator within an execution plan. So a coworker might ask me, come to my desk, look at the screen. I have this execution plan here, and it has three filter operators, the one here and the one there. I understand why they're there, but there's one here, and I have no clue what it's doing. Can you help me? So now he's looking at three different operators in the execution plan that all are a filter operator, but they are different instances of it. So the term operator is used both for the class and for the instance, and that is hell of a lot confusing sometimes, although usually within the context it is quite clear. And because this is the standard terminology, I'm not going to use other terms. I'm going to use operator in the same confusing, overloaded way. Okay, let's talk about the arrows. Like I said, they don't even exist at all. That's because an execution plan in SQL Server, it is internally represented in an undocumented and inaccessible way. Some people are very smart with trace flags and have access to a representation that is very close to the internal representation, but those are undocumented trace flags. I don't like using them, and I'm terrible at memorizing all those numbers. The best approximation of the actual execution plan that you can get is to look at the data that is transported from SQL Server to the client when you ask for an execution plan, and that is actually in XML format. And in XML format, you will not find the arrows. You will not find the data flows. They are represented by how other elements, the elements representing the operators, are arranged relative to each other. So Management Studio deducts how those arrows should be drawn from how the various elements in the XML are arranged. What the relevance of those arrows is that they represent which operators call which other operators. Like I said, many operators, when they need to do some work, need to get data first from another operator. In the execution plan, it is exactly laid out what operator they are allowed to call. And there are some specific rules that apply to every execution plan. First of all, each operator is called by exactly one operator. No more, no less. And that also means it returns rows to exactly one operator, the operator that calls it. In this relationship, we call the calling operator the parent operator and the called operator the child. So a parent asks its child to fetch a row by calling the getNext method, and the child returns by responds by returning a row to the parent. The other way around, there is no such rule. Every operator can call, many operators call one operator. So many operators have one child, but there are operators that have two or more children. And there are also operators that don't have children at all. They don't have to call other operators and can still return data because they use other methods. Based on those two rules, every parent has exactly one child. Every child has 0, 1 or more parents. What we have will be recognized by mathematicians as a tree, which is a term from graph theory. And in graph theory, points in a tree are called nodes. Now, why do I mention it? Because some of the terminology you will see when you talk about execution plans or work with execution plans use the word node. A node is the same as an instance of an operator, not a class. Now that we know about operators and about data flows and also about the call hierarchy in an execution plan, let's go through a few common misunderstandings that often confuse people. The first one is a very dangerous one, and I see a lot of people go wrong, not just beginners, but hardened professionals as well. And that has to do with the cost percentages that are displayed in execution plans. And I'm going to show a demo for that. If you look at the top of the screen, you see two very similar queries where the only change is in an option, a query hint. Basically, you should not use query hints unless, and the unless is very limited. So this is again a very silly example, similar to the dbo.delay that I used in the previous example. Let's imagine that those two queries are actual queries, so they're long, complicated, and hard to understand. This, the top one, is the query that was already running slow. And at the bottom, I have tried to optimize the query and make it go faster. Now, what I sometimes see people do is they select the batch with two queries. And in this case, I also have to select the assignment here because you cannot do anything without the declare. And the assignment is after the declare. But if I now ask the execution plan only, you will actually see three execution plans because the assign is also one, but let's ignore that for now and only look at the two real execution plans. A lot of people will zoom in and say, hey, one query has cost of 99% relative to the batch. That means that the other one is only 1%. That one is the one I tuned. I made it 100 times faster. I'm a tuning god. I'm awesome. But am I right? Then there are critical people who have not yet heard me talk about why I hate the terms estimated and actual. So there will be people who say, yeah, but this is the estimated plan only. So those numbers are estimates. You need to look at the actual plan. Then you get the actual number. So they enable the actual plan. That's the last time I'm going to use that word. I swear, I hate that word. They're going to execute the query. Weird difference. Now you don't get an execution plan for the assignment. You only get the two queries. And they say, hey, these are the real numbers. And it's still 99% for the slow query and 1% for my optimization. I really am awesome. I really made it 100 times faster. And then there are people who say, you know what, let's forget about the execution plan. Let's even disable the option. Let's look at statistics IO and statistics time to see how long each query ran and how much IO it did. So let's enable those options and let's execute the two queries again. Now I don't get an execution plan. I disabled that option. And now I can look and see that the first query took 16 milliseconds of CPU, 30 milliseconds of elapsed time, and 689 logical reads. And then I made it 100 times faster. Remember, 100 times faster. So obviously, now it took 62 milliseconds CPU time and 67 milliseconds elapsed and did almost 100,000 logical. That doesn't sound 100 times faster. That isn't 100 times faster. Okay, but surely now that SQL Server itself produces this data, surely if we now look at the execution plan, we will get the correct numbers, right? Let's double check again. The timing is now different because there's overhead for the execution plan, so especially the elapsed time is now higher. But look at the logical reads. It's still the second query much slower. My tuning has failed miserably. And yet in the execution plan, it still says 99% for the first query and 1% for the second. This data is completely misleading here. It's completely wrong, and by looking at it, I am misleading myself and wasting my time. So where does this data come from? Well, to understand that, I have to hover the select icon here, and I'll zoom in and show one thing that you see here, the so-called estimated subtree cost. On the select is the estimated cost in cost units, and cost units represent nothing except cost units. Some people like to call it query bucks, but I call it cost units. And the cost for this first query is estimated to be 0.584 cost units. Let's look at the second query. Whoops. Let's not scroll it. Let's just look. And here the estimated cost is 0.0065 cost units. If you do the math, that is exactly 1% and 99%. These numbers, this 1% is computed by Management Studio based on that estimated cost. But it's an estimated cost. It says literally here, estimated. It's not the actual cost. The actual cost isn't even measured. This is an execution plan with runtime statistics, but Microsoft saw no reason to include an actual cost computation. The only reason Microsoft computes costs is for plan selection. Once a plan is selected, Microsoft doesn't care about the cost anymore. So the estimated cost is in the execution plan, but the actual cost is not. Management Studio can only display data based on what is in the execution plan. So the 1% is based on an estimate. And often when you work with slow queries, and especially in the case of this demo, which was created specifically to demonstrate this, often when you work with slow queries, a root cause for the slowy is a bad estimate. If your estimate is wrong, that can result in bad choices, and that can result in a slow query. But if your estimate is wrong, then this 1% here is probably wrong as well. And yet people are looking at it and saying, see, this is faster. Which may be right if the estimates are all correct. But did we check that? Are we sure of that? And then there's another problem. What I also sometimes see is when people just have a slow query and are starting to work, they will execute the query, look at the execution plan plus runtime statistics and say, hey, this operator is good for 93% of this plan cost. So I don't need to look at the stream aggregate with 7%. I don't need to look at the rest with rounded to 0%. I only have to look at this clustered index scan. But again, this 93% is based on an estimated operator cost, and I'm going to highlight estimated again, of 0.54456. This is in the execution plan. The 93% you see here again is computed by Management Studio. It's not even in the execution plan. But it's computed based on the estimated cost of the operator versus the estimated cost of the query. All based on estimates, which is fine if your estimates are good, but wrong if your estimates are wrong. And that's why you should be very careful with looking at those percentages. As I like to say, it looks deceptively easy, but it's very easy to be deceived by those percentages. The prime reason, like I said, is that they are based on the estimated cost, which is incorrect if the estimated row count is wrong. But there can also be other reasons why those percentages are wrong. Cost units are simply a unit, a way to compare execution plans. They are based on hardware assumptions. And the sad matter of fact is they are based on hardware assumptions from the 90s of the last century, when a spinning disk with 7,200 rotations per minute was state of the art, when you were lucky to have a server with 16 gigabytes of RAM. Those are the hardware assumptions that are still at the heart of those costing decisions. So sometimes, even when all the estimates are correct, the cost estimates can still be wildly wrong. So am I saying never look at the cost percentages? No, I'm not saying that. But be aware that they are based on estimates and based on hardware assumptions that are probably not correct for your system. So they can be misleading. The other common misconception is the read direction. How do we read execution plans? And when I do this as a live presentation, I love to do a show of hands. Sadly, I can't do that now, but I like to ask the audience, who thinks we should read execution plans left to right? Who thinks we should read them right to left? Who thinks something else? And do you dare to explain to me what you think? A lot of people say right to left. And I understand why, because a lot of advice on the internet says right to left. But it's not correct. Let me explain why by looking at how an execution plan actually executes. Remember, all those operators have a get next method. We're going to ignore the initialize and close for now. Get next is the heart and beef of the execution plan. So select is not a real operator. It is an icon, but it is a representation of the client calling the main operator of the execution plan. So the select, basically the client asks the filter operator, hey, give me a row. Get next method. Filter, as many operators, says, I'd love to give you a row, but I need some data first. Hey, my child, table scan, give me a row. A table scan is one of those operators that doesn't have a child operator. It can actually access data in a table. So it reads data from a table and says, hey, here is a row. Filter, go ahead, here is your row. A filter is great at looking at rows and deciding whether they are great or awful. So filter looks at this row and says, no, I don't want this row. It's a bad row. I'm going to discard it. Table scan, give me another row. Sure, table scan says, here is another row. Have fun. And filter looks at this row and says, oh, wow, this is a great row. Select will love it. Here, select, here is your row. And the client will show it on Management Studio or do something with it if it's a C# program, and then call filter again for the next row. And that continues a lot of times. Now, if you look at the red arrows, and for those who are colorblind, those are the arrows running left to right and marked get next. Those show how control of flow works within an execution plan. They show how one operator calls another. And if you look carefully, the only reason table scan does anything at all is because filter called it. Otherwise, it wouldn't have done anything. The blue arrows that are the one going right to left without any text underneath, those represent the flow of data. But the flow of data is always in response to a call. So to understand an execution plan, in a complex execution plan, it is sometimes smart to follow the data. Just as police inspectors follow the money, execution plan inspectors often follow the data. So yes, often we do read right to left because we follow the data. But often is not always. There are elements in an execution plan that at runtime can decide not to call their children at all, or only call their children a few times instead of letting them finish. If you read right to left, you're pretending that the execution plan works push-based, that the tables can just start scanning data and pushing data instead of only returning data when it is asked for data. And you have to understand that sometimes there are reasons why it's not asked at all. Imagine looking at an execution plan starting at the far right, spending 20 minutes to analyze a complex sub-branch of the execution plan, and then encountering an execution plan that decided not to call that branch at all. So you wasted 20 minutes on analyzing something that never was active. That is why I never read left to right only, never read right to left only, but use a mixture. And that sounds like there is no easy way. Well, that's true. There is no easy way. The reason I have come quite fast at finding the spots in execution plans where I need to look is simply experience. I have seen thousands of execution plans, and over time, I get more and more experienced in understanding which areas are basic stuff that I can ignore and which areas are interesting and I need to look at. I'm not always right, but I'm way more often right now than I was 10 years ago. Questions about this part?
So Frank asks, there are two types of optimizers, cost and rules. The rule optimizer was abandoned. Maybe that will help when the estimate is just flat wrong.
As far as I know, the rule-based optimizer was not abandoned, but was simply never in SQL Server. I think Oracle has a rule-based optimizer. Like I said, I have read things about Oracle. I've never worked with the product, but I do know that SQL Server, as long as I have worked with it, and that is quite long, has had a cost-based optimizer. And as far as I know, there are no plans to change that. I don't know whether it would change anything because I don't know enough about how a rule-based optimizer works. I hope that answers your question.
It does, I believe.
More
The only other
questions?
question is, could we distinguish procedural code with set-based code by looking at execution plans?
Yes, you can. If you look at execution plans for procedural code, you will see that if you look at execution plans plus runtime statistics, you will see that some statements don't have an execution plan at all. Like for instance, a simple assignment, set variable equals value, or use database name. And some steps in the procedural code have each their own execution plan. So you get a lot of execution plans. If you run a while loop that runs a million times that does one select statement, you will get a million execution plans and you will probably crash Management Studio. So don't do that. If you look at execution plan only, then you will see an execution plan for each statement in the procedural code, all of them, even the ones that don't give an execution plan when you run the code. And they are all separate. We already saw that in the first demo when I didn't select anything. I'll go back to that demo. The first demo, when I select this statement and I ask an execution plan only, I get only one execution plan. But when I click somewhere so that nothing is selected, I get execution plans for everything. And then you will see that there are two execution plans, one for the use database statement and one for an actual query. In an execution plan plus runtime statistics, this first execution plan will be suppressed. I don't know why the product works that way, but that is a way to look at execution plans and understand, oh, this is a combination of procedural code and queries, or this is procedural code only. I don't know why you would do that in SQL, but you can, or this is just one single query. It's easier to just look at the query text because you can also see it there.
Awesome, thank you.
Let's look at the properties of execution plans. I like to compare execution plans to icebergs. They look nice and all, but most of them is under the surface. So the graphical execution plan that you see in, for instance, Management Studio is that tip of the iceberg that you can see. But underneath the surface, English is hard, underneath the surface, there you will find the properties, and they are a very important part of every iceberg and a very important part of every execution plan. Let's look at the demo. In the query window, you see two queries. And one uses select star, which you should never do, but this is just a demo. The queries are quite different. And yet, If I ask for the execution plan, and I'll slide this up a bit so that you can see them, you see the same picture 2 times. They look exactly the same. Now, if I tell you that the execution engine does not ever see the query, the execution plan sees only the execution plan and nothing else, then you might now think there are 2 identical execution plans. How can they at runtime produce different results? But the queries were different and they should produce different results. And as you see, when I run the queries, they do produce different results. The first query has way more columns and way more rows as well. The second query obviously skips a lot of rows and also has less columns. They don't return the same results, but the execution plans appear to be the same. So I had forgotten to include the execution plan plus runtime statistics. Let's look at the execution plans again. Like I said, they look exactly the same. How is it possible that they still produce different results? That is where the properties come in, and they are hidden underneath the surface, but we can access them. For instance, by hovering our mouse over an icon. If you hover your mouse over an operator, you will see a pop-up with a lot of properties. Everything you see on your screen are properties of this operator. And I'll zoom in now. One of those properties is called the output list. And this property includes, and yeah, execution plans love to use database name, the fully qualified name with database, schema, um, um, table, and column name. And as many parentheses and square brackets as they can get away with. But if you boil it down to the essence, there are 5 column names here. So the output list determines when you scan a clustered index, whatever that does, return those 5 columns only. And those are exactly the 5 columns that are requested for this second execution plan. Oops, that was scrolling too far. Let's do it like this. The first query asked for a select star, and here the output list is a lot longer. It's even incomplete. You see at the end an ellipsis saying it doesn't all fit on the screen. Also, the second clustered index scan, if I hover that one again, come on, there you are, has a predicate property where it says modified date larger to or equal to January 1st, 2013. Hey, that is exactly this where clause. So this clustered index scan doesn't return all rows, it filters while it is scanning a clustered index, whatever that is. This clustered index scan does not have a predicate property at all. So it simply returns all rows. So now that we have looked at the properties, you understand why those 2 execution plans that appear the same are in fact different, and how the execution engine will, based on those 2 plans, return different results because those properties are different. Now, I mentioned that the output list of this clustered index scan is incomplete. What if you want to see the entire list? What you can do is right-click and click Properties. And in my case, you won't see much happen, except that now this window here, and I'm going to move it now, activates. If you don't have this window active, I'll close it and show you. If you don't have it active, you can right-click and now it appears. I like to have it active because then I never have to right-click. If I click somewhere else, but for instance, on this clustered index scan, now you have the properties of this clustered index scan. Now you have the properties of the select. Now you have the properties of this arrow. But let's return to the properties of this clustered index scan. So if you work a lot with execution plans, I would recommend always keeping the properties window open, because otherwise you keep right-click, select the properties, and then close it again, and then open it again for the next operator. A simple left click is much faster. In this window, you will see all the same properties that were here, and a few more. There are more properties here. Microsoft made a selection of properties to include in this pop-up. Come on, sometimes it's a bit stubborn. This pop-up has just a subset of the properties. This window shows all of them. And in addition, like I said, if a property is too long, Then if you click here, you will see this ellipsis button appear. Click the ellipsis and now a new window opens, and you can resize that window as much as you want. I always click there to get the highlight gone, and you will see that everything is here. And if the list is longer, I can just make the window larger to read it all, or I can use the scroll bars that appear when the text is too long for the window size. So this gives you access to the full text of all properties. I'm going to dock it again. Whereas the pop-up is faster, but is incomplete. Before I forget, you can also hover or click an arrow, and then you will see a shorter list of properties. This is a very small subset of properties that actually are properties of the operator to the right. Remember, the arrow doesn't even exist in the execution plan, so it cannot have properties, but it can show properties of its child operator. And the subset you see here is focused only on the size of the amount of data produced and returned from clustered index scan to select. So if you only are focusing on the size, on the amount of data, then hovering arrows can be a very fast way to get a first rough indication. Now, like I said, you can hover over an icon where you get a subset of the properties, and I don't always agree with Microsoft's choices as to what they choose. You can hover over an arrow to get a very small subset focused on the data produced by the operator to the right of that arrow. Or you can right-click an icon and select properties, or right-click an arrow and select properties, or just click it when the properties window is already open. And that's the full list of all properties with the full text of all properties. Now you can also do it on the top left operator. And as I already mentioned, the top left operator isn't a real operator. It represents the client requesting rows. If it is not a real operator, how can it have properties? Well, it is the bin where all the properties are stored that describe the plan as a whole. Let's jump back into the demo and I will show you just that. So now I hover over the select and you see a very short list. The pop-up for the select for the top left operator is disappointingly short. But I will click it and then the properties window, and I will break it out again to have it in the center of the screen, make it a bit larger. This is a larger list. And this is still relatively simple because it's a very simple query. When the query gets more complex, you will often see more here. But there is already a wealth of information here. Things like the cardinality estimation model version. Which version of the cardinality estimator was used? How much memory was used when the plan was compiled? How many rows were estimated for this? We already looked at the estimated subtree cost, the estimated cost for the query. There is information about a thing called a memory grant. How much memory is needed for this query? There is information about properties of your computer that influence the optimizer. In my case, the available degree of parallelism is 4 because of the number of cores I have. This is the maximum memory grant it could have. Some things are very advanced, like what is a query plan hash? I'm not even going to explain that. Some things are very useful. Like here, how much CPU time and how much elapsed time when this query executed. I don't need set statistics time. I have it in the execution plan. There is also the wait stats. So I can click this and look at what wait stats there was. So I had async network IO wait for 5011 times for a total of 657 milliseconds. That's not a lot. But in the problem query, you will see the top 5 waits that were incurred while that query executed. A wealth of information, and you should always look at the properties of that select. They are properties for the plan as a whole. Sorry, I got a bit enthusiastic, but I am enthusiastic about this. For the properties on other operators, those describe things about that operator. And some of them can cause significant behavior changes, as we already saw with the output list and the predicate properties on the clustered index scan. Now, what do those properties mean? That is not in scope for this session. Just looking at the name, A lot are self-explanatory. But if you want to know everything, and the same goes if you encounter an operator that you don't understand, always go to the SQL Server Fast Execution Plan reference. It's not yet complete, but I believe I have 95% of the commonly occurring operators covered already. So almost always when you encounter an operator that you don't know, you can go to the execution plan reference and read what the operator does. If you encounter a property that you don't understand, go to the execution plan reference and read on that operator space or on the generic properties page what that property does. All that information is available. You just have to find it. Now, I believe we have time to run through one of the two examples. So let's quickly go to the last demo. And what I have here is a rather normal looking query on our sales. We just want to find the customer that ordered the most of a specific product ID 710. It's a fairly standard query on the AdventureWorks sample database. Let's ensure we get the execution plan plus runtime statistics and execute this. It's fast enough. So normally you wouldn't even have to bother about this execution plan, but let's just look at the execution plan. And you see, this is more complex than any of the examples I have shown before. And this can be daunting if you're just starting. Now, in this case, I have already looked at the execution plan, and in this case, there is no reason to not follow the data. So I'm going to follow the data and start at the right. At the far right is an index seek operator. And if you don't know what an index seek does, you can go to the execution plan reference. In this case, I'm here. I can tell you an index seek uses a non-clustered index to quickly and efficiently find specific rows. And which rows can be found in the properties of that index seek in the seek predicates property. So let's hover the icon. Let's zoom in. And you see here a seek predicates property that says, again, with all the extra parentheses and brackets it can put in, I'm looking for rows with product ID equal to 710. And it does that very efficiently because the actual number of rows returned is 44. And to find those rows, it only had to read 44 rows. So it didn't read a single extra row. It only read the rows it needed because the index supported searching by product ID. In this case, the estimate is also correct because the estimated number of rows is also 44. That's nice. It's always nice to see that an estimate is correct. So this index seek finds and returns 44 rows that have product ID equal to 710. What does it do with those rows? Let's first drag this down a bit and see that this 710 is, of course, a match for what the query says. Now, it's also important to look at what data is returned for those rows. By the way, I forgot to tell you, but I said an index seek searches in a non-clustered index. Here is the name of that non-clustered index. The index is called IX sales order ID product ID, and it's on the table sales order detail. So we're searching in the sales order detail table using this specific non-clustered index. And then we are returning two columns, sales order ID and sales order detail ID. So why are those two columns returned? If I look at the query, I can understand why sales order ID is returned because it's used for the join. But sales order detail ID is nowhere in the query. So it's a bit confusing that this column is returned. Let's put that thought aside for now. We'll get back to it later. But now look at what is done. So those 44 rows with product ID equal to 710 are then returned to the nested loops operator. And the nested loops operator, again, I'm going to save you the time of finding it on the execution plan reference. The execution plan, the nested loops operator will, for each row it receives from its top input, so for each of those 44 rows returned here, for each of them, it will execute its lower input and then combine the data as a way to do a join. Now, the lower input of this nested loops is a key lookup. And you see here that indeed the number of executions is 44. That means it has been initialized 44 times. It's not called for get next 44 times. That is the number of rows it returns. This is the number of times it was initialized because nested loops told it start from the top. And a key lookup is also a way to quickly find data in an index, but now it's looking in a clustered index and it's always going to return exactly one row. And which row is described here, and this one is really hard to read, but what it basically says is find me the rows with sales order ID and sales order detail ID equal to sales order ID and sales order detail ID passed in. Where are those sales order ID and sales order detail ID coming from? Where does this key lookup get its sales order ID and sales order detail ID? It gets it from the nested loops, because the nested loops says, and that's the outer references property, push sales order ID and sales order detail ID into your second input. So let's clear the screen. What we see is sales order ID and sales order detail ID are produced by index seek. It reads those columns, returned to nested loops. Nested loops then uses that to push those sales order ID and sales order detail ID into the key lookup. Yeah, I draw terrible. Key lookup then reads some data. We'll look at the exact data later, and returns that data for that specific row back to new nested loops. And that's why the sales order detail ID was returned by the index seek, because the key lookup needs it. And the key lookup will then return the order quantity. Now that makes more sense, because let's return to the query. Order quantity is in fact needed in the query. The index seek didn't read it because order quantity is not included in that index. So that's why index seek instead returned the columns that are part of the clustered index, so that the key lookup could then quickly find the order quantity for each row. And nested loops then combines that data to return, let's look at the output list again, the sales order ID, which is still needed in the rest of the query, and the order quantity. The sales order detail ID is now gone. The rest of the execution plan doesn't need the sales order detail ID anymore. But the sales order ID and order quantity are needed and are then returned by this nested loops to this nested loops. This nested loops then does a similar thing. It pushes the sales order ID, but only the sales order ID in this case, into its lower input. This lower input is a clustered index seek. That's very similar to a key lookup. It basically does the same thing, but without the guarantee of returning exactly one row. Although in this case, it does return. It's a bit technical why they two are different. They are not even that different. But here, the sales order ID is used to find the row we need, and then we can return the customer ID. So this second nested loops receives sales order ID and an order quantity from its child nested loops and adds a customer ID from here. It combines that, and now we don't need the sales order ID anymore, and we only return the customer ID and the order quantity. Why don't we need the sales order ID anymore? Because that was needed for this join, but we just did this join because this index seek and key lookup both read the sales order detail, and this one read the sales order header, and combined we have sales order header, sales order detail. We combine it here. So basically we have just found where in the execution plan this part is done, but also this part, because this where clause was hidden in this index seek. Now we see a sort. Well, that makes sense. We have an order by here, order by total quantity. So if we look at the sort, you might expect that it will order by order quantity. But in fact, it orders by customer ID. That's weird. Why does it order by customer ID? Again, let's put that question away and follow the data a bit more. Maybe it becomes clear later. The sort receives its data from the nested loops, still 44 rows, sorts them by customer ID, and then returns them to the stream aggregate. A stream aggregate does group by. Aggregation and group by are different words that mean the same. But a stream aggregate is one of two operators that can do group by. The stream aggregate only works correctly if the input data is sorted. Aha! Stream aggregate needs sorted data, sorted by customer ID. So to group by customer ID, the optimizer in this case chose to first sort by customer ID and then use an operator that requires the data to be sorted by customer ID. Well, the sort operator makes sure that that requirement is fulfilled. This stream aggregate then returns the customer ID column that we just grouped by, and two other columns called EXPR 1002 and EXPR 1003. The optimizer often creates new columns, and if it creates new columns, it always uses a mnemonic. EXPR is for expression, that's the most generic. You sometimes see more specific mnemonics, and then always follows that mnemonic by a 4-digit number that is unique in the execution plan. But how are expressions 1002 and 1003 computed? Well, that is sadly not in the pop-up. So let's look at the full properties. Yep. Sometimes clicking on something doesn't work immediately, then you need to click somewhere else and then click again, and then the properties window is updated. So here you will find the property called defined values, and that is where you will find the computation for new columns that are generated in an operator. If you click there and then click the ellipsis, and I will zoom in again, you will see that EXPR 1002 is computed as, and again, there's a lot of fluff, but if you zoom in on the relevant part, you will see it's count star. And EXPR 1003 is computed as a sum of the order quantity column. Hey, that sounds familiar. A count star and a sum order quantity. That sounds very, that sounds very familiar because that's exactly what we have in the query. So the stream aggregate returns 3 columns, the customer ID, and the 2 EXPRs that represent exactly the columns we have in our output list, the customer ID and the amount of orders and the total quantity. But it's not sorted by total quantity yet, and that's why we have a sort again here. And this sort will indeed order by total quantity descending exactly as we have in the query. But it's not a regular sort. It says here it's a top n sort. And a top n sort is a specific subset of sort where, apart from sorting the data, it also removes everything after the first n results. You can find the value of n in the properties. Let's scroll down, and here you will see the property top rows equal to 10. So it does a combination in one of a sort and a top. There are separate operators for sort and top, but if they are adjacent, SQL Server will often combine them into a so-called top n sort because that's slightly more efficient. And that is, of course, because in our query we asked for the top 10. So it has to be sorted. We do want the top 10. It could be done with 2 operators, but SQL Server combines this. And that is how this entire execution plan goes through all the data and eventually returns what you need. Now, I'm going to very briefly look at the second query. There's only one change. Instead of product 710, we're looking now at product 711. You might expect the same execution plan, just with a different seek predicates in the index seek. So I'm not executing this yet, so we still have this query. You might expect when I go to the second query that here this 710 is changed to 711 and the rest is the same. And with many values that will happen, but not with the value 711. If I use 711 and execute it, I suddenly get a very different looking execution plan. And the simple reason for that is that based on looking at product ID 711, the estimated number of rows is now suddenly 3090, not 44 anymore. And with so many rows estimated to be returned, the original plan of doing a seek and then a nested loops into a key lookup became more expensive. And it became cheaper, estimated to be cheaper, to read everything from both indexes and then do a so-called hash match. Hash match, like nested loops, joins data, but it joins it in a different way. It uses a different algorithm. The aggregation is now a hash match aggregate that doesn't need the data to be sorted and again uses a different algorithm. The only part that stayed the same is the top end sort. So simply because more rows were estimated to be returned, the plan changed. Now in this case, the estimate is correct. So likely both plans are optimal for their data. But if the estimates had been incorrect, then we might have been looking at a plan that is not optimal for the data. So like I said, I have some further reading tips. There is a book called SQL Server Execution Plans, and I'm going to highlight third edition. The third edition was a complete rewrite. The first and second editions were okay, but the third edition is really great. It's much improved in many ways. It's a very good guide from getting started to the intermediate level, and it's for free if you just want a PDF. I have made a tiny URL so that you can quickly find it. If you want a book copy, then you can order it from Amazon.com, but it's not for free. If you want to find in-depth information about operators, about properties, go to the execution plan reference, sqlserverfast.com/EPR. If you want to learn a lot more, you can buy the execution plan video training, and remember the code DBA Fund will give you a 10% discount until the 15th of June. That should have been on the slide, but I've forgotten to put it there. There's lots of good courses on pluralsight.com. And also I have a session that is intended as a follow-up session to this one that talks to more complex execution plans and shows how you can actually use it to solve real-world problems. That is planned to be held for the DBA Fundamentals Virtual Group in, I think, September. So if you're interested, tune in then as well. That's all I have for now, unless there are still open questions. I believe we still have a few minutes. So if there are any questions, ask them now.
So actually, there aren't any more questions or comments, either one. As always, this is great. I have thoroughly enjoyed this. I've actually learned a few things about execution plans, so all good.
Awesome. I'm glad I was able to teach you something.
So perfect. Yep.
Nobody
Looks
typing
like
any
we
last
are
second
all
questions?
good.
Okay. Well, I believe that's it then. Thanks for having me. It was awesome to be here as a guest presenter. I'm already looking forward to returning in September. And
Thank you, Hugo. Thank
as I
you.
said, if you have any questions that didn't come up now or that you want to discuss in private, mail me, tweet me. I will try to respond to all questions.
Perfect. Thank you so much. And with
You're
that,
welcome.
we have come to the end of another great presentation from DBA Fundamentals. If you'd like to join us next time, please join us. The next one is May 30th. It's Caleb Ellie, the Magnificent 7 and Beyond Intelligent Query Processing in SQL Server. So again, that is on May 30th. Please be sure to sign up and join us then. But until then, we'll see y'all on YouTube as always, checking out some of our great presentations. Thank y'all so much.